So myself, Mallesham Devasane. So I do take the classes for TOC, CD, and C programming, and I may aware of many subjects, but these are the usually taking subjects for GATE. And C programming depends on time, I may or may not take, but assume that these are well-known subjects for me. And I did my MTech from IIT Bombay. And almost 15 plus years of experience so far. In the GATE, as well as other domain like training placements, placement training programs. Also, I do take the classes. And yeah, this is all about. In case if you want to know more about, like, you can search my name on LinkedIn, you will get all the details what I have done. Okay. So this subject is very easy, for preparation of GATE. Like 80% of the subject is so easy. Other 20% you should know how to deal it. Right? You are not mastering the subject, but you should know how to deal with the subject. They may not ask proofs. That's why you are safe for a GATE preparation. Are you able to understand? They will not ask algorithms. That's why you are safe for the GATE exam. So you should know the answers rather than proving it. So this subject, if you are trying to prove everything, you will fail. So, but some things you prove, but many things you understand. That is very important. So in this theory of computation, the weightage for the GATE exam, and this year it went up to 10 marks, looks like. And now we can predict like 8 to 10 marks weightage is given to this subject. In 2025, the weightage is in paper 1, I saw 10 marks. So that means it is one of the important subject compared to other subjects too. After aptitude, if you see more weightage to any subject, that one of the subject is also theory of computation. Okay, what is there in theory of computation? Anybody aware? How to study this subject? We have few topics, like we have regular languages. First, we'll start with introduction, because you should know the basics, right? And the second, we will study the regular languages. So big topic, 50% of the time it will take regular languages. Third, CFLs and DCFLs. Fourth, recursive languages and RELs. Fifth, last topic, which will be undecidability. Now, what is the important of this subject is, here you should spend the 50% of the time. Remember this point. And more than 50, maybe 60% you spend there. And the 20% of the time you spend here. And maybe 10% of the time you spend here. And maybe 10%. And here you can see 50 to 60%. And 5% of the time you will spend here, not even 5% too. The questions are very rarely asked from introduction. Okay. Getting the out of 10 marks, if you look at the weightage, maximum weightage will be here, right, in the second topic. So that is the reason we spend half of the time, many weekends, only to understand what is a regular language, right? Are we ready to start? And do you require any textbook? As far as my knowledge, if you are attending classes regularly, you do not require any textbook. But if you have any textbook, any standard textbook, you can refer. I never say don't study textbook. You study textbook when you have a time, right? Already you are spending enough time to understand the lectures and you will write the notes. Then that would be sufficient for the GATE exam. But what else is required? You require to practice. Like, you watch the video, and what are the steps that you follow? Watch, and then notes, you make the notes, and you need to start practicing now onwards, and you should do revise, and these things should be done repeatedly till the end of the exam time. Other, if you don't do revise and practice regularly in a month at least once, this subject will become new when you look at it, when you sit in November or December if you are going for revision. Believe me or not, you will be having more than 1,000 questions only in the class itself. Okay, believe me or not, more than 1,000. That 1,000 is the minimum for me, right? So I don't know where will I reach. Only the problem is how many you practice, how many you understand, right? In TOC, once you understand the theory, here you can solve 1,000 problems easily, even one concept also. Just like programming knowledge. Once you understand the problem, you can write your own logic, right? Okay, you please follow this till the end of the preparation and don't stop after completing TOC. Don't stop doing revision and practice. Revision is important, practice is important, so that you will get a confidence. How many times you should do? As long as you have the time. Okay, let's begin the subject. In introduction, what we study. Do you have any doubts? Please post in the chat box. In introduction, our agenda is what is TOC? Then we immediately will begin some of the applications. Okay. Then we'll start basics directly. Okay. This TOC is mainly for understanding computation, right? How we compute. And how to, measure. Not only just compute, it also helps us to measure the problem solutions. The compute, we will have a computable theory. So TOC, whenever you study a subject, there is a theory called as computable theory. So what we study in undergraduate, BTech, will study just computable theory. There is another theory to measure the complexity. You will be having complexity theory. Like, right, in algorithms, you study order of big O of n, big theta of n, n square. So how do you measure the complexity of the solution? Getting? So TOC will help you in both the ways, computable and measurement. So if the problem is computable, how better you compute? If the problem has a solution, then how better we can measure? So both of them are dealt using the theoretical model, which is called as theory of computation. Okay. Anyhow, that's about TOC, and in entire subject you are just going to understand how to compute, how to understand the solution, how to represent. Okay. Logic. Applications. Any limitations of the application? These concepts are used almost in every subject in the world. Every subject in the world. It's not just computer science. Because without a computation, you can't do anything in the world. Everybody agree? Every minute, what you think is just computation. But no need to represent every time the computation in a particular model, right? When you have a problem, you are not able to put into a practical, then first we design theoretically, then we'll do practical implementation. Everyone agree for that? You cannot go sometimes when the problem is so big. First, you build a theoretical model. Then, example, our buildings. Directly, we don't go. First, we make a model. That model is nothing but automata theory. Okay. So, applications example where you might be seeing this. Have you seen traffic light? Have you seen traffic light? It's one of the model in TOC. So theoretically, we have a model so that practically was easy to build. And not just this one, compiler, C compiler, C++ compiler, Java compiler, all these compilers initially modeled how this phases of the compiler works. Then later we have built it. Not just compiler, this TOC is used in even artificial intelligence in various ways. The Turing machine helps in understanding different computations or different models in AI. So is there any limitation for this theory of computation where you or you may not use it? There is no limitation. If there is a computation, you can always approach TOC either theoretically or practically, whatever. Okay. There are many, like in electronics, we will have like mobiles, computers, laptops. All of them are, automata models. Getting my point? When you go for the computer science programs are nothing but automata, theoretical automata models. Like if I have a program, that means I believe that I have a model with us. Okay. When you go for electrical engineering, you will have circuits. When you go for mechanical engineering, you will have motors or some other, right, machines. And similarly, when you go for civil engineering, they have different instruments for building. So all are automata or theoretical models. They are directly or indirectly related to the subject. Okay. So have you understood? This theory of computation is one subject where you can relate any subject, any computation. You can relate with any computation in the world. Got my point? Of course, you don't require where it is, right? You have the subject, learn all the concepts. Maybe practically you may not use it, but you'll understand how this can be applied. Just like that, you studied a lot of subjects so far. Are you applying in day life? May or may not. But this is a subject where in every moment, today, if I wake up and what time I should wake up, that's kind of modeling, right? So you are thinking about it and you are trying to solve it. So you are actually, this theory of computation is trying to do the computation. Okay. So what is this? Before starting the basics, why this TOC is very popular in the world is because we have the problems. Correct? These problems need to be modeled. So these problems we represent as languages in this subject. And these languages, we try to compute it. We build machines. Machines we call here automata, or many other names are there. So this is how we try to understand how to compute using theory of computation. In real world problems, we'll convert into languages, and that languages we build a machine to understand. Right? And in this process, you need to learn a lot of concepts, how the problems will convert to languages and how the languages we can build a machine. This entire process will take much time. And do you think every problem you have a machine? No. And some problems are basically computable or not computable. So if the problem is computable, that means we have a solution. And problem is not computable, that means we don't have a solution. Okay. All the computable problems, they have these solutions. You can easily understand. Not computable problems, they may not have a solution. Okay. Are we ready to start? Before starting, I want you to engage. Like, you never sit quietly. And those people who wanted to learn the subject without any difficulty, only the ways you need to engage. So far, I was just giving overview of the subject, like what is this about? It's about just solving the problems in the world. Just I want to compute, then you need a model. That models you can come to TOC to understand. Let's begin. In the basics, we learn a lot. And do not compare any of my previous lectures with this lecture, because I always try to introduce some different concepts and different ways to approach. Uh, Maybe concepts are same, but approaches that I follow is up to me. Do not ever compare with my previous courses from anywhere, okay? Because all looks sometimes different. In this basics, we learn something called as symbol. Then we learn alphabet. The same process we learn alphabet. Then we'll go for string. Then we'll go for language. Once we complete them, we'll go for very interesting operations that could be applied on strings or on languages. Okay. you can apply anywhere. Depends on operation that could be applied to many. Then you will begin to understand why we are studying this subject here. What is there inside? How it can help us, the entire world, this Chomsky hierarchy. Then we will understand, oh, we have the problems that we can represent language, and you will have automata, and you will have grammar. So you are going to learn these concepts in the basics. Okay. Please note down. The first topic of our TOC is the basics. In these basics also there are a lot of gate questions. That is the reason you should study this, and this is also foundation for entire subject. And let's begin with the first line: symbol, alphabet, string, language. Okay. Okay. What is symbol? We'll read the definitions as soon as we understand examples. Okay. First, we will focus on what are these terminologies. Anybody aware? In any language that you see in the world, it could be English or Hindi, Telugu, Tamil or Japanese or any other language you take in the world, they will have all of these four terminologies, right? They'll have the symbols. There is alphabet for them, and so that you can write words, so that you can form a language. That's why people like P.V. Narasimha Rao, you know, right? He had, more than 15 languages. How is that possible, learning many languages to a single person? Because when we follow all these four systematically, it is possible. Only the thing is, you should practice it to speak those, uh, sentences, and to remember them, you need to have a regular practice. Okay. Getting? So let's start with the known ones. First one. If I'm using 0, 1, these two are my symbols. Okay. 0 and 1. What could be corresponding alphabet to represent those two symbols? And alphabet we represent like a bracket set. All the symbols we collect and we keep here, and we call it as binary alphabet. And when it comes to string, you will form, if you don't want any symbol, then we call here special string epsilon. When somebody write epsilon means I don't want even symbol. Like example, you have written a program, sometimes without input also it works. So you are not giving input means you are giving epsilon. Not giving input also works the program, right? When somebody, even they don't speak, you will understand. That's called as they are giving you epsilon input. So epsilon, nothing but is special string. We'll write a definition soon. Okay. Don't worry much about it. 0, 1, 00, 01, 10, 11, and so on. Infinite number of strings are there. And what do you mean by language? You take some strings from here and form a set. We call that as language. Language is nothing but a set only. Even that alphabet is also a set. Remember, it is also a set. But this set has the symbols, this set has the strings. Both sets are different. Even this is also a set only. but this set is called as is having symbols, and this set is having strings. And you may not have a string, sometimes we call empty. We may have only one string, you may have two strings, you may have even many strings, and in fact you may have even infinite number of strings. Correct? Are you able to understand? We are going to start definitions, but before that I want you to look at what are all this about, and how do we can relate one with other. When it comes to your mathematical decimal system, you will be having 0 to 9, and all the symbols, when you keep inside, we call it as alphabet. And here the strings we can call numbers in mathematics. You may have, like, when you don't want to write anything, you may have 0, 1, 10, 123. Like, you can have any number, and all comes under your strings. Yes, great. Please respond in between. And when you form a language, then you can form a language like epsilon, 0, 00, 10, whatever. Right? Even sometimes you can form 0 power n, 1 power n, such that n greater than or equal to 0. Right? All these are languages, right? You are able to understand 0 power n, 1 power 2n, something like that. They represent languages. And the third, let's talk about English language. Like, you have A to Z. If you have even capital letters, you can also keep them. And all of them, when you put in one set, we call it is alphabet. And when you form a string, it just looks like word. Sometimes you may not understand the word, but that is in, maybe you don't keep in English dictionary, right? So language that you can form, like, so what is symbol? Now I'm asking a question, first question, after showing everything, what is symbol? What you understood from this slide? Anyone? I'll come to the definitions, don't worry about all. Anything that you don't understand, leave it. I just want you to focus on what are these definitions. If I give direct definitions, then you don't realize what is the meaning of it. Now you have an example in front of you. This represents symbol, this represent set, this represents some kind of sequence, and this is called as collection. What is symbol here? Separate characters, good. Symbols are basic building blocks of language, good. Go ahead, go ahead. Good answers will come when you discuss. Basically, symbol is nothing but smallest in the world, right? That means whatever I take, doesn't matter what I take. Again, whatever I take here, that you should assume is the smallest in your problem. Correct or not? Uh, So symbol has no particular definition. Whatever you write is called as a symbol in the world. Remember that. Whatever you write, I may assume that is a symbol. And using that, all the symbols when you put in a set, you call alphabet. What is alphabet? Nothing but it is a set, but which has all symbols. All symbols. This one we represent with sigma. Yes or no? Sigma, delta, tau, gamma, many notations are there. Sigma or capital A, capital B, you can also use that names. Alphabet is nothing but a set of or collection of all symbols that you wanted. And this should be always finite number of symbols. If you have infinite symbols here, and alphabet is also infinite set. When you have an infinite set, how do you understand a language or strings? Okay. Language can be infinite, but not symbols, remember. And what is a string? A string you may represent with a W most of the times, but not required to represent using W. You can use U, V, X, Y, whatever. And string nothing but it is a sequence. If you take any string, what do you see in that? Symbols, they are formed in a sequence, right? So it is a sequence of symbols. How many symbols? It could be 0 or more. If 0 symbols, you will get epsilon. If one symbol, you will see like this. 2 symbols, you will see 2 length. And if you have 3 symbols, you may have 3 length. A string is nothing but a sequence of all symbols. And what is the language? And in these strings, you collect some or as per your requirement. It is also set but of strings. Okay. So everybody able to map to the definition? And first they don't need to worry as basics, right? A symbol, maybe a character, maybe a digit, we don't care. Maybe a letter. Different languages use the different word for the symbol. You wanted to know? If you look at a binary language, a symbols will be what? 0, 1. We call them as bits. Yes or no? The symbol we call as a bit. And string we call number, binary number, right? Like 0, 0, 0, 1, 1. We call here number. In TOC, everything we call string and everything we call symbol. But here you have a bit as a name in binary language. And when it comes to decimal language, bit means binary digit, remember. Here we call, here you have what? 0 to 9, I guess. And then here you call digit. Which digit? Decimal digit. Each one is a digit. And when it comes to string, we call it as a decimal number or integer number. And when it comes to English language, we'll write A to Z or lowercase or uppercase. That's okay. We call here letter. What do we call here? Letter. English letter, English alphabet letter, something like that. But letter should be used to understand this A to Z. And in C programming also, it's also language, right? C programming language. And what do you have here? You will have A to Z. We'll have even 0 to 9. And many, right? Plus, minus, all. So C programming also we have symbols we call here as characters. Here English we call letter, and that string we call as a word. Like we form a word here, right? Like teacher. Here we call as characters. What we call here? Character. Here we call anything you write like main, temp, plus, minus, and so on. Here everything we call is a token. What do we call here? Token. Able to relate? In the world there are so many languages. When you go to the language, their name may change, like symbol we call in TOC, but in different languages we have a different name for the symbol: bit, digit, letter, character. And when it comes to strings in our TOC, here their name changes depends on the topic, like numbers, decimal numbers, octal numbers. I'm not writing all of them, but you can understand. Words in English we call, and then C programming called tokens, because you need to group the symbols or characters into a token. Okay. Yeah. So before, I'll just give the definitions, then we'll move. We'll focus more on, let's say, assume that sigma is equal to a comma b, alphabet, right? And here we are going to understand the strings first. Once you understand the strings, we'll go for the languages. Now, how do you form the strings? I'll wait, just sit for some time. I'm just a little bit tired. Uh, I'll wait for your answers. What do you mean by string in this alphabet? Because every alphabet we have a string. We have strings. That's it. I want to write strings. Yes, there are infinite number of strings, true. Yeah, Nipun is right. Any combination of two, A and B. Here, string is nothing but sequence of symbols defined over the sigma only. Remember, if I miss that point, how do you frame a string? You will frame a string based on these sigma only. Sequence of symbols, but how do you take the symbols? From this alphabet only. So if I have a 0, 1, I can frame the string using 0, 1, not with a 9, Z, whatever else. Now here the strings, when you don't write anything, epsilon and A, B, what are all about? If you keep writing it, you have many, right? You have many. Now I have a doubt. When you take a i- string over any sigma, right? What is it? Is it finite or infinite? The string, is it finite or infinite type? What we call finite string or infinite string? Both will be there. What do you mean by it? I didn't ask how many strings. Number of strings are infinite. What is each string? Is this finite or infinite? This is finite or infinite? This is finite or infinite? What is each string that is used in the computation? What do you mean by one string? Is it finite type or infinite type? I want everybody to answer. Just so basics. One of the gate question depends on this statement. Yes, every string is a finite. You cannot write infinite string in the computation. Remember? So each string that you see here is a finite type because you have number of symbols is finite. Here no symbol, one symbol, two symbols, and here three symbols in a sequence. Okay. Of course, to frame a language, you can take 0 or more strings from this. You will get a language. And it is called as empty string. What is it called as? Empty. This is one length strings. Here, two length. Correct? Yeah, let's talk about the string. String is a sequence, right? What is a string? You take any string, there's a sequence of symbols, right? 1, 2, 3, 4, 0, 0 symbols, 1 symbol, 2 symbols in a sequence, 3 symbols in a sequence. In general, if you take any string, right, it is a sequence of symbols, right? And this sequence always contain finite. This is a finite sequence. You cannot have infinite sequence. If you are writing, suppose infinite sequence, let's say you are writing like this. This sequence is what? Infinite sequence. And this string called as infinite type string. Infinite type. You can also call infinite sequence. And this one is called as finite type, so finite string. In general, in a theory of computation, which string we consider? String is two types, obviously, but which string is considered for computation? Number of strings infinite, but string type is finite. So finite string, such strings, how many are there in our language or in over the sigma? Infinite, correct? So what we consider for computation, for theory of computation or for computation, we just need string type should be finite. Okay, type. String type should be finite. Means how many symbols should be there in the sequence? That this kind of sequence not used in computation, not used anywhere in general. Because how can you write a string which is infinite? You can form a language which is infinite, but you cannot form a string which is infinite. Everyone? So we call finite string. Finite number of strings, there is a different meaning. Finite string. Now come to the language. Now sigma is equal to a comma b. You have a lot of strings, right? Epsilon a b double a b b a b b and 3 length. So many are there. Now we are talking about a language. What is a language? Is nothing but collection of strings, right? Collection of strings. Now understand how many ways you can form a language. Like one language I can form which has nothing, means no string I want. So pi. I want only one string. One string, how can you form? It may be empty string or it may be only a, correct? It may be only b or it may be only double a. If you are looking at one string languages, how many are there? You're writing only one string, but such languages are how many? Infinite languages are there with only one string. And I'm just forming, let's say, L6. I'm forming two strings, let's say. How many such strings, how many such languages I can form? With only two strings. With only two strings. Infinite number of languages I can form with only two strings. With 3 strings, 4 strings, 5 strings, correct? Suppose I'm writing a power n, where n greater than or equal 0. This is infinite language. Even I can write a power n, b power n, where n greater than or equal 0. Here, how many strings are there? Infinite number of strings are there. How many? Infinite number. Yeah. Now you tell me, I'm just asking the question. Symbol. I want a type. I want count. How many? What type and how many? I'll write a definition to understand. Take over the sigma only. Over sigma. Can you try the answers? Let's see how many of you can answer now. So let me answer it properly. Each symbol is a finite type because it is just one length, we call it as. What we call it is the one length. So definitely finite only. each symbol, when you look at in the sigma, let's say sigma is a comma b. What is a? A, length of a has to be 1. Length of b has to be 1. The 1 means it's always finite, correct? And how many symbols that you can write in a sigma? How many symbols that you can put in a sigma? In any alphabet in the world, it should be finite. You cannot put infinite symbols in your alphabet. If there are infinite symbols, when will you understand the strings and when will you form a language? Like English, A to Z, right? For decimal numbers 0 to 9, binary numbers 0 and 1, right? So it has to be finite. For this one it is binary, and some other sigma could have more symbols, but every alphabet will have finite number of symbols. String, each string or whatever the string you write, it has to be which type? Finite type. Of course you can write infinite, but that is not used in computation. A number of strings, how many you can write? For the given sigma, you can form infinite number of strings you can form, not 1, 2, 3, correct? For the given sigma, you give me any sigma, put at least one symbol in it, you can form infinite number of strings, 1 length, 2 length, 3 length, 4 length, 5 length, 6 length, you will never stop. And language, when you go for language, language can be two types, right? It is either finite or infinite. You can form any type of language. Number of languages, how many you can form? Again, infinite. We have seen, right? With one string only, you have infinite number of languages. With two strings, infinite. Total overall, how many languages are there? Infinite number of languages are there. Right? Any confusion, let me know. I'll make you clarity, then we'll proceed further. So, language is, each one is either finite or infinite. Anuj Kumar. Each language can be anything that you want to write, correct? You can write as a finite or infinite, that you can take, but total number of languages in the world over the sigma is infinite. That is what your world depends, right? For program, I'll just relate. For program, can you give input is infinite? If the input is infinite, when will the output comes? For your brain, you are keep giving knowledge, right? You are studying, but when will you, remember it? You cannot give infinite thing to the, any problem. Like your string is also just one input. If the input is infinite itself, then when will the output comes? Every string should be finite type. That length has to be finite. Clearly told, right? In the previous slide, I clearly mentioned. And what are you doing that time? Correct? The string has to be finite so that you can take it and you can understand whether it is valid or invalid, or what can we do with this. If the string itself is infinite, how will you understand? How will you understand the 3 dot? What are the things are there? Even you understand how do you use in computation, okay? Right. In not just you see, in anywhere in the world, you will write as a finite one. Like every word in the dictionary, every word in dictionary, is it finite length or not? Every number in the world that you study, is it finite or not? Every name that you represent or write, is it finite or not? Every city name, every state name, every country name, any name that you study, it has to be finite length or not? Okay, that's same as string only, no? Okay, it's just common sense. Okay, it's not just, it's a completely the string has to be this. No, not that way. You can write your own sigma, you can frame your own string, you can frame your own language. Remember, you can do whatever you want. That's why it is a theory of computation. You have a problem, do whatever you like it. Example, sigma is equal to okay. I have given a few questions for you. Please answer it. I'll number it if you want it. Assume this is 1, 2, 3, 4, 5, and 6, 7. Whatever you mention in the sigma, you just assume it is x, y, z. Are you getting? It could be double A or triple A. That we don't have any meaning inside. You cannot break that symbol into further. You should remember that if it is looking like two length, but when you're talking about English language, but that's not English language. They are creating own alphabet. When they are creating their own alphabet, you should follow them. That means whatever they write before the comma or in between the commas, everything just called as one length. That means whether it is 1, 2, 3 or double A or whatever it is just called as what length? Length 1 only. Everyone got this point? Sir, double A, how it could be one length? Double A is two length in English language. Who said I'm talking about English? We are creating own alphabets. We are creating our own language. Then the double A is not double A anymore. It is called as a symbol for us. Even spelling may change if they want to. And here, A in English language is a one length, but in our language, A has no meaning. Double A has a meaning. That's a one length. A has no meaning. No meaning to them. Okay. But they are at least one length because they are belongs. Now, double A is repeated twice because double A is one length. One length followed by one length will give you 2. And 1, 2, 3 is one length, double A and 1, 2, 3, which will be total 3 length. If you are confused with 1, 2, 3, double A, 1, 2, 3, replace with this X, Y, Z. And here, this is a one length and double A is another length, so we'll get 2 length. I think most of you have catched that point because what is the symbol you are already aware. Correct? Okay. Let's start with the strings. Operations. You can apply to strings. And you can also apply to language. When you're applying to strings, you can concatenate. You can do concatenation. You can do reversal. You can find the length of a string. You can apply some properties like prefix, suffix, and substring. When it comes to language operations, you can apply like mathematical union set, intersection, complement, reversal, difference. Even you can also apply like prefix, suffix, substring here also. Okay. There are many operations in both of them. Right. Now, is it important to learn all of them here? No. Everybody? Just aware like, okay, we have operations. I'll give examples just to understand, but do not worry much about them. Okay. Like string 1 is AB and string 2 is, let's say, triple A. And what is W1, W2? Which W1 is AB, W2 triple A means W1 followed by W2 you will write. That's a concatenation operation, and in between dot is not compulsory. You can put a dot or you no need to put. Both represent W1 followed by W2. Right? Reversal. We'll talk about all these operations later in closure properties. Right now we don't discuss much. Suppose W is equal to AB, and what is its reversal? BA. Length, suppose W is equal to AB, what is the length? Length we represent with the cardinality symbol, right? It is 2. Oh, only when the sigma is A comma B. If the sigma changes, your answer changes. Prefix of W, let's say prefix of W, you are talking about AB. You can take 3 length also if you want. Suppose you want to find a prefix of ABA, then what will you get? You'll get epsilon, you'll get, so always string begins from big, in this position. So you can take A or AB or AB. A, AB or AB. So you need to understand more about what is the prefix. Just I'm writing. Suffix of, let's say, ABA. How do you write suffix of ABA? Epsilon, and always the ending sequence you have to take A, BA, ABA. So A is there, BA is there, and then ABA. So you can call it as ending sequence of symbols. This one is a beginning sequence. So you will start here. You can take any length of the string. And suffix means you should stop here. So you can start anywhere. Substring, suppose if I take ABA, epsilon, AB, no restriction. It should be part of the string. That's it. Double A is you can't form it. AB you can form. And then BA you can form. And overall string too. So you should understand how do you form a substring, prefix, suffix, and we will work on them too. As it's a very basics class, don't worry much about all these things, correct? So in future, when we are learning these operations, we'll come to this again and we'll discuss more in detail what is prefix, suffix, substring, how many prefixes, how many suffixes, what is the definition of a prefix, and all we'll discuss much in detail. Today is the first class, even I'm not much keen to understand or explain all these points. Okay, are we ready to go for Chomsky hierarchy? We'll practice some questions at the end. What does this all TO say about? Why we should learn all these concepts here? Okay, this Chomsky invented like whole world is divided into few classes. This is a class. And this class name is given as, okay, I'll give later. There is another class here. He made total 4 classes, and each class he has given a name, one particular type of the class. All right. So this class name is called as type 0. And this one is type 1. And this one is type 2. This one is type 3. What do you mean by this class? What do you mean by this class? Class has infinite problems inside. Remember that the class is given to understand. Oh, Nivedita, is everybody facing the same issue? No, right? Okay, that's okay then. Nothing, today class is just for fun. We actually not driving deep into the subject. We are just looking at outside. Okay, this is TOC. It has languages, it has strings, it has symbols. Are you able to understand? Today, at the end of the class, only remember TOC is all about symbols, strings, languages. Everybody, and about problems. These 4 points you should remember. A problem I want to represent, you need a symbol, you need a string, you need a language. Every problem we convert into a language. Okay. What is the relationship between these types? This is the type 3 is inside type 2, means subset of type 2, and type 2 subset of type 1, type 1 subset of type 0. Got it? The relation between these classes, the type 3 class is also called as set of all regulars. This type 2 class also called as, it is a set, it's a set which has every CFL in it, including this set of all context free languages. Set of all context sensitive languages. Set of all recursively enumerable languages. Okay, the various classification we have, and the Chomsky divided the entire world into few classes to understand. Okay, and to design a machine for this kind of problems, we have, suppose you are talking about a type measurement. Let's talk about this type 3. Which language is there inside? Is there in the type 3 is regular, correct? Here context free language, here context sensitive language, here REL, recursively enumerable language. If we don't know the definitions or abbreviations, we'll see later. CFL means context free language. CSL means context sensitive language. And REL means recursively enumerable language. And for this language, we have a machine to understand that we call here finite automata, PDA, push down automata, linear bound automata, and Turing machine. Again, to understand these abbreviations, you can write here finite automata, push down automata, linear bound automata, and Turing machine. And when you look at the relationship between them, finite automata is less powerful because it knows only smallest class, right? And this Turing machine knows a bigger class. That means all of the three are covered here. So when the language is REL, whether it is regular or not, CFL or not, CSL or not, you will follow the same point. And for every REL, you will design a Turing machine. And all these three languages are already REL because they are part of the RELs only. Grammar. What grammar you will use here? Regular grammar. And this regular grammar is again two types, LLG or RLG. You can use any of these grammars. For CFL, we have context-free grammar. For CSL, we have context-sensitive grammar and length-restricted grammar also. And this one is unrestricted grammar. Yeah. So this is all about the Chomsky hierarchy relationships. And in case if anybody want to relate, like finite automata is less powerful than PDA, and PDA is less powerful than LBA, and is less powerful than Turing machine. More powerful, and this less powerful. Easy to understand, but and remember some of the important points. Every regular language is CFL, so CSL, every CFL is, you can say CSL, RL, but you cannot say every CFL is, you cannot say regular. Similarly, other relations also will hold. Okay.